Okay, now the world of horizontal asymptotes and vertical asymptotes, especially horizontal because they're the ones. Vertical asymptotes are so visual you can really kind of see them quickly, but horizontal asymptotes. So I got two rules here. The first one says if the degree of the numerator equals the degree of the denominator, the horizontal asymptote equals the ratio of the leading coefficient. Okay. The second one says if the degree of the denominator is greater than the degree of the numerator, y equals 0 is the horizontal asymptote. All right, so what does it mean to have degree? This is probably the first thing we need to talk about. The degree of something. So if you had a polynomial that was like, I don't know, x squared plus 3x plus 1, the degree of this is 2 because that's the highest exponent. So this has degree 2 because of that. Okay? The highest exponent is the degree. The leading coefficient is the coefficient that's with the highest degree exponent. So the degree of this would be 1. Okay? Or the leading coefficient, rather, would be 1. The degree is 2. Let's look at another one. Let's say I had 2x to the third minus 2x. Well, the degree of this would equal 3, and the leading coefficient would be 2 because that's the one that's multiplying the highest degree variable. One more. Let's say we had x plus 1. Well, the degree of this would be 1 because this is x to the first power, and the leading coefficient would be 1. These are called here, here, and here are called leading coefficients, which is super important because this says the ratio of the leading coefficients. So we need to know what that means. So before we graph this example here that I have, this is example 1. Before I graph 4 over x minus 3, let's look at it. So let's see which one of these two rules this thing satisfies. So 4 over x minus 3, the degree of the numerator is equal to the degree of the denominator. Well, the other example I didn't put up here is what happens if you just have a number. Well, that's like, this is degree 0. This is degree 0 because that's actually x to the 0 power plus 4. That's actually what that means because anything to the 0 power equals 1. So this is a degree 0. So this is, or it's actually, yeah. So this is degree 0. This is degree. What degree is this bottom? Right. I'm writing over top of my graph here. I did make a small boo-boo right here. This 4 is actually 4x to the 0 because that's 4 times 1, which equals 4. That's how that is. Not x to the 0 plus 4. Sorry about that. So this is degree 0. Not that it really matters. This is degree 0. This is degree 1. So this is where the degree of the denominator is greater than the degree of the numerator. So this thing is going to have a horizontal asymptote, Asymptote, equal to y equals 0. So this thing is going to have, which is basically the x-axis. It is going to have vertical asymptote, Asymptote. It's going to have a vertical asymptote at x equals 3. Let me show you why. If we were to graph this, all right, so I just graphed this, and you can see what the green line looks like. Well, there's a vertical asymptote that I want to talk about real fast, going right down through here. It's not actually part of the graph, but this red dotted line is the vertical asymptote, and it's basically equal to 3 because that's, if you plug in a 3 here for that x, that makes that bottom equal to 0. So I have 4 over 0, which is undefined. Undefined. And if something is undefined, it has a vertical asymptote right here. These two rules here are what makes the horizontal asymptote. So let's look at another example. You may want to watch that again. That was pretty fast. Let's look at a slightly more difficult example here. This time I have a big old function, and I'm going to pause it and let's all graph it back. All right, so I went ahead and sketched a picture of this graph, and you can see that the red vertical asymptotes, let's talk about the vertical ones before the horizontal ones. The red vertical asymptotes are at -5 and -1. And the reason why is this bottom here factors. This bottom factors into two binomials, and it would be x plus 5, x plus 1. So the numbers that you could plug in for this x and this x, making it equal to 0, would be -5 and -1. Thus, we're going to have two vertical asymptotes at those points. So you would say that if you had to list these, the vertical asymptotes would be x equals -5 and x equals -1. Now, what about the horizontal? Horizontal, ASY. Well, you got to figure out which of the two rules this follows. What is the degree of the top? What is the degree of the top? That's right. This is degree 1. And this here, what's the highest exponent on the bottom? 2. It is degree 2. So we can see that the degree of the denominator is greater than the degree of the numerator. So its horizontal asymptote is y equals 0. If you did have one, which I'll do in another video, where the top degree equaled the bottom degree, then you do the ratio. Let me just do one real fast here. So let's say we had 2x squared and 3x squared. Well, what I mean by these have the same degrees, these are both degree 2s. The ratio of the leading coefficients here are 2 and 3. So the ratio of those is 2/3. So it would have a horizontal asymptote at 2/3. So it would be up a little bit and have this horizontal asymptote. And I'll make another video on that. Talk to you later.